In this example, we will antidifferentiate sine squared times cosine squared. Going back and looking at the guidelines we have for evaluating integrals of the form sine to a power, cosine to a power, we see that if both of the powers are even, the suggestion is to rewrite in terms of the half-angle formulas. So let me remind you that the half-angle formulas tell us that cosine squared of, and I'm going to say of something. Typically it's an x, but here we'll see in a moment why I'm going to use just a blank. So cosine squared of something is going to be 1/2 times the quantity 1 plus cosine of 2 times that something. And similarly, sine squared of something is 1/2 times 1 minus cosine of 2 times something. So putting these formulas to use are something that we're going to immediately plug in as x. So sine squared is 1/2 the quantity 1 minus cosine 2x. And cosine squared is 1/2 the quantity 1 plus cosine 2x. And immediately we can do some nice algebraic simplifications. 1/2 times 1/2 pulls out front as a 1/4. And what we are integrating is 1 minus cosine 1 plus something. But this just gives us our difference of squares formula. It will be that first thing squared, the 1, minus the second thing squared, cosine 2x. So we can take our integrand and break it up into two pieces. You have maybe the simple piece to deal with, 1/4 times the antiderivative of 1. Then we have minus 1/4 times the antiderivative of cosine squared of 2x. So we can easily take care of this first antiderivative. We'll just say 1/4 x. Now to take care of this second antiderivative, what we have to do is once again make the observation that whenever we're integrating and it's just even powers of cosine or sine, we rewrite via these half-angle formulas. So we need to rewrite via this first half-angle formula. So cosine squared of something, so for us the something that we're plugging in the box is 2x, is going to be 1/2 the quantity 1 plus cosine of 2 times 2x. So this is where we have to be very careful applying the formula. So rewriting the integrand, we have 1/2 multiplied by 1 plus cosine of 2 times 2x. And we simply could write a 4x there, but I want to make sure that we see exactly where this is coming from. Whatever is inside that cosine squared needs to go here in our formula. And now we can continue on. The 1/4 x comes on down. 1/4 times 1/2 is 1/8. And now we can antidifferentiate term by term. The antiderivative of 1 is x, and the antiderivative of cosine 4x is 1/4 sine 4x plus c. And just to make sure if you are not quite seeing where this antiderivative came from, inside the cosine 2 times 2x is 4x, so you could certainly apply the substitution u equals 4x. And lastly here, I'll just go ahead and maybe combine two terms here algebraically. 1/4 x minus 1/8 x is 1/8 x. The minus sign distributes through, so we'll have minus 1/32 sine of 4x plus c.